Hello friends, welcome to Joy of Life. So today we are going to do another medium level problem. The problem number is 107. It's binary tree level order traversal 2. So I thought of completing this entire set of binary tree level order traversal problems that is there in Leetcode before continuing with any other videos. Look at this problem and try to understand and leverage what we have learned so far in order to come up with the solution. So it says that given the root of a binary tree, return the bottom up level order traversal of its node's values, that is from left to right, level by level, from leaf to root. So it is very similar to the problem that I have done before, which is binary tree level order traversal, the simple one. So there what we did was we did a top to bottom and left to right. But in this case, we are going to do a bottom to top and left to right. So given a tree like this, 3, 9, 20, 15, 7. So 15, 7 should come first, then 9, 20, then 3, right? We are doing a bottom up, right? So we are going to look at the solution, but before looking at the solution, as I always recommend, do give it a try yourself. This problem is going to be very same, just like the binary tree level order traversal. So I highly recommend that you watch that video, you understand that problem, and this is just an extension to this problem. So that program that we have done um, needs a little bit of tweaking in order to come up with the solution. So in this video, I will not go very detailed on the level order traversal part. So please check that video. I'll leave a link in the description below this video so you can refer anytime. And I'll also leave a card somewhere over here so that you can refer to that solution as well. So we'll move over to the board quickly and you will try to understand how we are going to do that. So I have taken a tree over here and I am going to go a little quicker compared to my earlier video. This is more of a quick recap that I'll be doing over here for this problem. So what we did basically is we took a queue, right? So this was our algorithm, right? So let's go by the algorithm, but let's go it really fast. So we have a list of integer result that we have to return back. Then what we do is we add the root of the tree to the queue, right? So what essentially happens is one is added over here, right? Iterate until the queue is empty. We start iterating and every time we get the size. So let's say I get the size 1, so I will iterate this one time, right? And we are going to poll and add the left and the right child if they are present. Otherwise, we don't add them. And we have a list over here wherein we add the integers, the value from the node to the list. And after the end of this iteration, we used to add the result to the list, right? So what will happen is first we'll have multiple list over here. So let's start with say the first list. So what I'll get over here is a size 1. So I'll be polling out 1. So 1 comes over here and we add the childs of 1. So childs of 1 are nothing but 2 and 3. We go to the top, we get the size, we get a size 2 and we create a new list all over again and we iterate from 0 to 2 and we poll. So first time we poll, so we'll have a subsequent list over here. So we poll, we get 2. So what we do is we add 2's child. So we add basically 4 over here and there is nothing more to add. We poll again, we get a 3, so we get the 3 over here. So this list is nothing but this operation that is indicated over here, right? So what happens is 3's child is added back to the queue again. So 3 has 2 child, 5 and 6, so they come over here. We start iterating all over again. So we go to the top, we see that the queue is not empty. We start iterating by creating a new list and we poll 3 times. So first time what we do is we take 4 out, 4 has no child, so 4 comes over here. Then we get 5 out, 5 has no child, so 5 also come over here. Then we take out 6, 6 comes over here and 6 has a child which is 7. So we add 7 to the queue and this list terminate and we go to the top and we start building a new list and this time we get a size 1, right? So we pop out 7, we add 7 over here to the list and at the end we have a this res list of list as this guy over here. So 1 2 3 4 5 6 and then 7. So these are the 4 lists that we have, but the only problem with this approach is we have done a top down. So one easy way, there are two ways to do the solve this problem now. So this is pretty much a top down approach, but we need a bottom up approach, right? So one thing that you can do is over here you can reverse this list, right? So you can just do a collection dot reverse and get this list reversed. Or there is one more technique that you can add probably over here is you take a stack and which holds a list of integers, right? So let's say this is called stack, right? So what happens is we don't do this part over here. So instead of this line over here, that rest.add, what we do is we push to the stack. So every time we push this list to the stack, so what happens is we do this. I have a stack over here. So let's say this is my stack. So what will happen is this list will be pushed here. This is my first element, first reference. Then I will get this list and put this reference over here. And then I put this reference over here. So I'm just pushing into the stack, right? So this is the last generated list. So this will be, this will have a reference over here. So we can just put the reference into the stack. And then what we can do is a small part over here. So iterate until stack is empty. So we are going to iterate and we are going to do a pop. So what will happen is we will get a reference, right? Will get this reference. So we are going to add this reference to my res. So that's it. So what will happen basically over here is when I start popping out, I will get the last list first, right? So I'll get this instance first. So I'll be putting that instance on the top of my list, right? So my first list item would be 7. Second one, when I pop out, I get this, right? So the instance that I'll be getting is a 4, 5, and a 6. Then I'll get this one, which is a 2 and a 3. And then finally the last one, which is a 1. So I will have this stored in a bottom-up approach, right? So let's implement the solution in Leetcode and let's get that done. So what I'll do for the coding part is I'll just skip over the normal traversal part and then I'll show you the modification. So yeah, this is the basic code that we have done. So what we did is if the root is null, we are returning back the empty list. Then we have taken a queue and we have added the root to it and we are iterating until the queue is not empty. We got the size, we created a list and we are iterating till the size. We are we are pulling and getting the tree nodes. We are checking left not equals to null. Then we are adding to the queue, right not equals to null. We are adding to the queue and then we have added the element to the list, right? And we have to return the result. Somehow our result is not ready now. So we are going to see the stack approach. So what we are going to do is we are going to build a stack. So this stack will just hold the reference to your this list, right? So this has to be a list of integer. And let's call it a stack, which is a new stack, let's say, right? And what we are going to do is we are going to add to the stack every time we create this list, right? And we'll require an additional loop over here while stack basically while stack is not empty, we are going to iterate it and we are going to add to the result. So we have created this as result, right? Dot add and since we are popping, so we'll be getting in the reverse order. So we are going to do a pop. So yeah, that's it. We are, oops, this one is my bad. Let me change this and this one would be le dot left and le dot right. I've just put right and left. Okay, so let's run and check this. Well, it has been accepted. So let's do a submit and check. Perfect. It has been accepted and we have a submission which is pretty cool. So yeah, this is all about the solution. This is a very simple thing if you understand how to do a level order traversal, right? So you can have two approaches over here. So one is the stack approach over here. So let's understand the complexity part. So there is a reverse also, but we are not using any inbuilt function. We are getting things done by ourselves only. So for the runtime complexity, we have a loop over here where we are iterating uh, through the queue. And what does the queue hold? So the queue holds almost all the nodes, right? So it touches all the nodes basically. This is the runtime that we are talking about, right? So for the first loop, we will have a order of n complexity, right? And then we have a loop over here, right? So what is the maximum level it can travel? It can go. So the second loop that we have over here, where we are getting data from the stack. So the it will be the order of max depth of your tree, right? So these are the two things that's going to factor in your runtime complexity, right? And for storage, what we have a queue. right? So what is the worst amount of data this queue is going to hold? So this queue is going to hold 2 to the power of max depth, right? This is the maximum we are going to hold. So again, I'm reminding you, if you haven't seen the earlier video, please check that. I'll drop a link on the description below. So that will give you a clear understanding, and this is just an extension of it, right? And we have a stack. So how much your stack is going to hold? Your stack is going to hold order of max depth, right? Whatever depth you have, it's going to hold that, right? So if there are 4 levels, there will be 4 reference stored in the stack, right? So once again, I'm just reminding you that if you haven't seen the video on the level order traversal, do check it. It is just the extension of that same video where you will understand why we have this complexity and how we are storing and doing the traversal. It will give you a very clear idea about it. So yeah, this is going to be our runtime complexity and the space complexity. So I hope this video was helpful to you. Do let me know in the comment. Do share, subscribe with your friend. Let the channel grow. And yeah, that's all. I'll be creating more videos. I think there are 3 back-to-back videos that I've created on the level order traversal. If there are any more down the line, I will do that for sure. And if not, I will jump over to some other topic and I'll be creating some videos tomorrow. So what I try to do is to create videos every day so that you get to learn something new every day and try them out. Do try them out. I appreciate that you are watching this video till the very end, till here. So I'll also recommend that once you check out this video, do try to implement them and try to solve the problem on your own in Leetcode or in any IDs that you use, maybe IntelliJ or Eclipse, whatever you are using. That will give you the next level of confidence in order to come up with better code and to improve on your coding as well. If you are stuck when you start writing your code, you will definitely find areas wherein you will feel that you can write much more improved code than the one I have written. That's where you really start growing, and that's what even I try till date. So do let me know if you find a better solution or you think there is any possibility of improvement for me. I'm always open to any suggestion, comments. So yeah, that is all from this video. Do like, share, and subscribe if you haven't done so. And yeah, keep supporting the channel. It's good to see it's growing, but yeah, at the same time, I would love to hear back from you guys. Do leave a comment for me. Do let me know what I'm doing good, what can be improved, what is going bad, and things like that. If you want me to solve any particular problem from any platform, Leetcode or any other platform, or any offline problems, or any particular topic that you want me to make a video like this on, then do let me know. I'll try my best in order to come up with such a video. Yeah, so that's all. Have a great day. Enough of Gyan I have given in this video once again. So see you guys soon again. Bye bye.